Hello everybody, welcome to Chapter 6.4 Part 1, Rational Exponents. Converting a rational exponent to a radical expression. In general, when the numerator equals x to the 1 over n, it's equal to the nth root of x. In general, when the numerator does not equal 1, x to the m over n is equal to the nth root of x to the mth power. In the expression x, the top one m is the power and the bottom one n is the root. Write each expression as a root and then simplify if possible. So we will do that for example number 1, 8 to the 1/3 power. So let us look at the whiteboard and see how to do something like this. So here we have a situation where 8 is equal to 1/3. Well, what this means is the cubed root of 8, and the cubed root of 8, because we have to multiply the same number 3 times, is saying 2 times 2 times 2 will give us 8, and that means that this is going to be 2. Reviewing what we did in number 1, when we convert 8 to the 1/3 power, we can convert that into the cubed root of 8, which is equal to 2. In number 2, we have 36 to the 1/2 power. So let us go over to the whiteboard and see how I do that one. 36 to the 1/2, or what does that mean? That means, because it's 1/2, 2 on the bottom, that means that this is the square root of 36. And we know from earlier that 36 is a perfect square, and 36 is equal to 6. 6 times 6 gives us 36. In number 2, we saw that 36 to the 1/2 power is really the square root of 36, which is a perfect square equaling 6. In number 3, we have negative bracket 25 to the 1/2 power. So let's look on the whiteboard and see how to look at this one. Now for number 3, we see that we have negative, and I'm very careful putting that bracket, 25 to the 1/2. So that negative is outside of my bracket. So all that we're concerned about with the 1/2 is that 25 itself. So we can just write the negative outside the square root sign. So now we have 25, and then we know that 25 is a perfect square. So there we have -5. In example number 3, we found that when the negative sign is outside the bracket, we also put that outside the radical sign. So that means that the square root of 25, which is a perfect square, is 5, and then we just carry the negative over. In example number 4, we have now the negative inside the bracket. So let us go over to the whiteboard and see how example number 4 would be different from what we did in example number 3. If we have a situation where the negative is inside the bracket, must be very, very careful. This means that the negative sign is also inside the root sign. And in our case here, as we discussed earlier, if we have a negative inside the square root sign or any even power root, that is imaginary, or it is not real. And we'll talk about what we mean by imaginary later. We just found that when we have the negative sign inside the bracket, that this is not a real number, but something called an imaginary number that we would call 5i. We'll learn a little bit more about imaginary numbers later, but for now, we could say that this is not a real number. In example number 5, we have a fraction inside the bracket, and we bring that to the 1/2 power. So let's go over to the whiteboard and see how we deal with a fraction brought to a fractional power. 5, where we have actually a quotient. So we have 4 over 9 is to the 1/2. Well, we've already seen that 1/2 is like a square root. So we use our rules. So that would be the same thing as 4 to the 1/2, 9 to the 1/2. And that would be the same thing as the square root of 4 over the square root of 9. And since we know that 4 and 9 are perfect squares, it will be 2 over 3. In example number 5, we just converted it into a square root of 4 over square root of 9. And the square root of 4 we know is a perfect square, and the square root of 9 we know is a perfect square, so we got 2/3. Converting a rational exponent to a radical expression. Recall the properties of exponents. Let a and b be real numbers, and let m and n be integers. The product of powers property. So the a to the m times a to the n is equal to a to the m plus n. Power of a power property. A to the m brought to the nth power is a to the m times n. Power of product property. ab to the m is equal to a to the m b to the m. Negative exponent property. A to the negative m is equal to 1 over a to the m, where a is not equal to 0, because if a is equal to 0, that means it is undefined, and we don't want that. The zero exponent property, well, anything brought to the 0 power is 1, so long as a is not equal to 0, because again, that would be problematic. Quotient of powers property. A to the m over a to the n is equal to a to the m minus n, where again a is not equal to 0, because if a was equal to 0, then it would be undefined, and we don't want that. Power of a quotient property. Well, here is when we have two different things inside, and we have a over b. That would be a to the m over b to the m, where b is not equal to 0, because if b is equal to 0, that means again we would get it undefined, and we don't want that. In example number 6, we're asked to write the radical cubed root x to the 6th y to the 12th with a rational exponent, and then asked to simplify it. So let us go to the whiteboard and see how we would do this. We're going to write this expression with a rational exponent, and then we're going to simplify. So we remember the powers are on the top and the root is on the bottom. So we can rewrite this with our power. So that would be x to the 6th, y to the 12th. But we're going to rewrite that as 1/3, since it's a cubed root. Now we're going to use our rules. So we're going to do 6 over 1 times 1 over 3. And then we're going to have y 12 over 1 times 1 over 3. And again, I'm just using that 1 as a place mark so you don't get confused about what I'm doing. And that means 6 times 1, so that means we have x to the 6th over 3. And here we have y to the 12 over 3. And then we simplify, because 3 goes into 6 2 times, and 3 goes into 12 4 times, and that will be our final answer.
In example number 6, we saw that the bottom number of the fraction represents the root and the top number represents the power. So we did it accordingly and found 6 over 3 and then 12 over 3, and ultimately we got x squared y to the 4th. In number 7, we're asked to write the radical 4th root 81r to the 8th s to the 20 with a rational exponent and then simplify. So let us go over to the whiteboard and do this one.
We're going to look at this 81 r to the 8 s to the 20. And we're going to do the same thing. So first we have in here, we're just going to put that in a bracket here, 81 r to the 8th s to the 20. And we see that it's going to be over 1/4 since it's to the 4th root. Well, we have 81 to the 1/4. And then we have r to the 8 over 4. Then we have s to the 20 over 4. And if we can maybe figure that out, but it turns out that if we multiply 3 times 3 times 3 times 3 4 times, we're going to get 81. So it turns out that this is 3. 4 goes into 8 2 times, so that's squared. 4 goes into 20 5 times to the 5th, and so this becomes our final answer.
We saw on the whiteboard that we took all of this because it's to the 4th root, and we put 1/4 up here. And then we have 81 to the 1/4, r to the 8th to the 1/4, s to the 20th over 1/4, and then we just multiplied it in. So we get 81 to the 1/4, r to the 8 over 4, s to the 20 over 4, and simplified that to 3r squared s to the 5th. The rational exponent theorem. If a is a non-negative real number, m is an integer, and n is a positive integer, then a to the m over n is equal to a to the 1 over n to the m is the same thing as a to the m to the 1 over n, which is the same thing as the nth root. In example number 8, we are asked to simplify 8 to the 2/3 as much as possible. So let us go over to the whiteboard and do this one.
Using some of these ideas, we look at the following examples. 8. So we have 8 and 2/3. So we can rewrite that as 8 and 1/3 squared. Well, we know that the cubed root of 8, because that's what 1/3, 8 to the 1/3 means, is 2. So now we see that it's 2 squared, and that's 4.
Reviewing what we just did in example number 8, we looked at 8 to the 2/3 power, and we put the power outside of the bracket, and we put what will eventually become the cubed root inside, and we use the rational exponent theorem to do this. We then use the definition of fractional exponents. So here we have the cubed root of 8 is equal to 2, So we get 2, and then we have it to the second power, and that is how we got 4, because 2 squared is equal to 4. In example number 9, we're asked to simplify 25 to the 3/2 power as much as possible. So let's look at this one on the whiteboard.
We have 25 to the 3/2. What that means is we have 25 to the 1/2 cubed. And it turns out that since 25 to the 1/2 is the same thing as 25 squared cubed, so that means that's equal to 5 cubed, and it turns out that 5 times 5 times 5, which is 5 cubed, is equal to 125.
Reviewing what we did on the whiteboard in example number 9, we put the power outside of the bracket, so we see that 25 is to the 1/2 power, which is the same thing as the square root of 25, and this is the rational exponent theorem. Since the square root of 25 is 5, we now raise it to the 3rd power because that's outside of the bracket here. And that's from the definition of fractional exponents. And that's equal to 125. In example number 10, we're asked to simplify 9 to the negative 3/2 as much as possible. So let us go over to the whiteboard and see how we deal with a situation like this.
To the negative 3/2, and we go about it the same way, where the 9 is to the 1/2, and then we have the negative power. Negative 3 power. Well, then we go about it using our usual rules. Well, we know that the square root of 9 is 3 and negative 3. And we know from earlier that if we have something to the negative power, that means it would be 1 over 3 to the 3rd, which is the same thing as saying 1, because 1 times 1 times 1 times 1 is 1 over 3 to the 3rd, which is equal to 1 over 27. So remember, we're just applying those rules of exponents that we learned in the first lesson this semester of the 56th part of our course.
Reviewing what we just did in example number 10, we put the negative 3 on the outside and the 1/2 on the inside of the bracket, so we see we have now the square root of 9, and that's from the rational exponent theorem. Then we know that the square root of 9 is 3, so now we have 3 to the negative 3 from the definition of fractional exponents. And then using our exponent rules, because it's a negative power, we have to put it 1 over 3 cubed. And then 3 cubed is 27, so it's 1 over 27. In example number 11, we're asked to simplify 27 over 8 to the negative 4/3 power. So let us go over to the whiteboard and work this one out.
Here we have 27 to the 8th over 8 to the negative 4 over 3. Now, of course, there are different ways you can do this, but I'm going to do it by bringing the cubic in here, 1/3 in there. So now I have 27 over 8 to the 1/3, and then on the outside, negative 4. So now I know, well, this is one of the cubed roots you should know, because that would be the same thing as saying 27 to the 1/3 over 8 to the 1/3 to the negative fourth. Well, we know that 27 cubed, the cubed root of 27 is 3, and the cubed root of 8 is 2, and that's going to be the negative 4, but we know when we have a negative power like that, we can just make that equal to 2 over 3 to the 4th power. And that's the same thing. I'm just going to continue it. As 2 to the 4th over 3 to the 4th, which is the same thing as 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. So you can go about it if you don't know what that's all equal to. So, and just multiply it through. And what you get is 16 over 81. And 16 over 81 would be your final answer.
Reviewing what we just did in example number 11, we saw that if we bracket this, we put another bracket and put this to the power, and then what's inside here to the 1/3 power, we see we have perfect cube of 27, and also 8 is a perfect cube. So 3 is the perfect cube of 27, 2 is the perfect cube of 8. Now we have the negative 4, and again we use our exponent rules. So we turn it upside down, and 3 over 2 to the negative 4 becomes 2 over 3 to the positive 4. And 2 to the 4th power is 16, and 3 to the 4th power is 81, and that is our final answer. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.